Okay, so today we get to begin Unit 3 packet. So hopefully you have your packet out in front of you, and we get to open it. Here we go. We're going to talk about functions, and we're going to talk about graphing this unit, and we're going to do all kinds of things. And I think you're going to find out that you're going to like this unit a little bit better. Well, not better, but it's fun too. So I enjoy this one. So here we go. We're going to start off by talking about just basic information. This is just kind of a basic information video. So we have a relation. A relation is just a set of ordered pairs. Okay, that's all it means, is we put a bunch of ordered pairs. So you can see one right down here, and we're going to look at several examples of how you can write a relation. Okay, and we've been doing it, you just didn't know the name of it. Now, a function is a specific relation. Okay, because your relations, all of the problems that you see on the worksheet in front of you, the packet in front of you, those are all relations. But a function is a special one. A function is a relation in which each input, which are usually your x values, is paired with one and only one output, or y value. So most machines are functions. You put something in, let's see, I have a cheese grater at home on my KitchenAid. So if I put cheese in the top, the grater is like a function, and when it comes out, I get shredded cheese. So that's a function. My cheese grater is a function, just to let you know. Sorry, yes, it is a function. I put in one, and I can only get shredded cheese when I come back out. That's all I can get, because that's how the machine works. That's how the function works. So what we're going to do now is we're going to look at a whole bunch of relations, and we're going to talk about if they are functions. Are these functions? Okay, so you know me well by now, and this is a wonderful math definition, and that's what we do, but here's what I remember, okay? If it is a function, no x values can repeat. No x values can repeat. And that's what this sentence says here, with one and only one y value. Now, notice it's an x values cannot repeat. You can have all the same y values, not a problem, to be a function, but no x values can repeat. So what we're going to do is we're going to find out if these are functions. We're first going to look at just ordered pairs, okay? So this ordered pair, we have our x values, our x values, our x values. Nothing repeats. Yep, it's a function. Okay, no x values repeat. What about here? X value, X value. Do we see any of them that are the same? Whoa, whoa, right there, right there. Okay, not a function. So this is when we're just given set notation. Now, we're going to be given tables. It still works the same way. Exactly one x value for every one y value. So here we go. Do I have any x values that repeat? Bam, right there. Those two x values repeat. Not a function. And once we get to the next page, I'll show you even a better way to do it. You'll see. Anyway, okay, look at this. Do I have any x values that repeat? Nope. Now look at those y values. They're all the same. This is what I mean. This is a function. Yes, a function. Okay, this is a function because no x values repeat. My y values are all the same, but that doesn't matter. It's the x values. Okay, now we're going to move to what's called mappings. Now with mappings, what it's doing is it's saying this goes with 4, 3 goes with 8, 4 goes with 8, 5 goes with 5. Okay, so what I have to do, because it's just a little hard, sometimes that gets confusing, so I write out the ordered pairs. I have the ordered pair 2, 4. I have the ordered pair 3 and 8. I have the ordered pair 4 and 8. And I have the ordered pair 5 and 5. Okay, do you see I just took and wrote down the ordered pairs, 2 and 4, 3 and 8, 4 and 8, 5 and 5. Those are my ordered pairs. So I took a mapping, and what this does is 2 maps onto 4, 3 maps to 8, 4 maps to 8, 5 maps to 5. For me, it's easier if I can look at them in ordered pairs and look at my x values. Do they repeat? Nope. This is a function. Yes, a function. Okay? Do the same thing over here. We're going to map our inputs to our outputs. So 4 matches to 7, 5 matches to 2, 5 matches to 9, 8 matches to 5. And some of your brains might be fine with that. Mine is not. I need to actually write out the ordered pair, so I'm going to do that again. 4 and 7, 5 and 2, 5 and 9. Bam! We're done. That's not a function, because look at that right there. Not a function. But I just have to finish it. Okay? Can't just sit there and not have them all written out. So these are my ordered pairs. I see that my x values repeat right here, so not a function. Okay, next page. See, easy stuff. Okay, now we're going to be given equations. Okay, with equations, what we have to realize is there are some equations that are and some equations that are not. And that's a really hard thing to do until we get to another part of it. If I have a linear equation, wow, if you knew some other stuff first, it would be lots easier. So I'm going to go down here to graphs. I'll come back to equations. So in a graph, we have this really cool test that we do. And it says to determine if a graph is a function, you need to apply the vertical line test. That's what it's called mathematically. I, of course, have another name for it. I call it the pencil test. Okay, let's see what this vertical line test is. It says, for each value of x, imagine a vertical line passing through it. If the line passes through only one point in the graph, then the graph represents a function. So, when I say a pencil test, what I like to do is, if I put my pencil down, does it hit the graph more than once? It's really easy to see on these. We'll come back to those. So what it's saying is that my line, my vertical line, my pencil can only touch the graph once as it goes down. Now, here my pencil touches, but it only touches it once. Here it touches, but it only touches it once. So that you can see it a little better, let me show you with a ruler. So let's do this vertical line test. See how my ruler only touches the graph once here? Touches the graph once here? Touches the graph once here? So yes, this is a function. Because the line only touches one point at a time. Oops, can't read that. Functions. Yes, it's a function. And the reason we use a function is because the line only touches one point at a time. Now, it can touch the graph lots of different times, but every time it's only once. So see my pencil test? Okay, come over here. The pencil test is pretty easy on this one. Look at this one. Bam! Is this a function? No, it hits it twice. Now here it only hits it once, but any place on there, if it hits it more than one point at it, sorry, if the vertical line comes through and touches more than one point at a time, then it is not a function. Not a function. And you could even draw a vertical line in. See, look. Right here, not a function because my vertical line touches twice. And you could draw a whole bunch and you'd see. The only place it will touch it once is right out here on the vertex. But this is not a function. Okay, so moving back up to these two graphs, I'm going to use my ruler instead. So here we go. Touches once, touches once, touches once. Whoops, right there, look at that. Touches twice. When I draw my vertical line down through it, it's going to touch it twice. So not a function. Okay, good. Do B. Try it. Go. So is B a function? Once, 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 once. See how it only hits it once, 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 once. So yes, it's a function. Oops. I'm spelling yes with a T now. Okay, it's a function. Okay, good. Let's go back up and look now at those equations. Okay, so let's look at equations. Of course, my mind first goes to let's just graph it, but we haven't done a lot of graphing yet, so let's talk about another way to do it. One of the ways we can do it is we can see, let's pick some x values. If I plug in 1, I get 3 times 1 plus 2, I get 3 plus 2, I get 5. If I plug in 1, can I get any other answer? What if I plug in 2? Can I get any other answer? No. So that's the reason this one is a function. And we'll find that pretty much any linear equations, makes a line, would be a function. We'll get more into that later. Don't worry about that right now. Okay, now on this one, let's say that I pick x, and I'm going to pick x is equal to 3. So I get y squared is equal to 3 plus 1. So I get y squared is equal to 4. Now, what's happening here? Okay, we know how to do this, so then we take the square root of both sides, and we get y equals 2. But here's what we haven't really covered much. If I take 2 times 2, do I get 4? Yes. If I take negative 2 times negative 2, what do I get? Hopefully you all said 4, right? So this answer has 2, and that's what we didn't get into when we were solving, is that we actually have 2 answers when we take a square root, a positive and a negative. We just didn't have to worry about it at the time. So this one is not a function. And if you were to graph this one, just in general, it would look something like this, okay? But it could actually go around. Oh, wait, hold on. Okay, we're not going to get into the graph right now because that brings a whole other thing up. My graph was correct, but it doesn't matter right now. Okay, so real world. Input, a person's identity. So that's what we're putting in. When we put in a person's identity, can we get more than one social security number? No, everybody gets exactly one social security number. So yes, this is a function. Okay, this one, a person's age. So when I put in a person's age, well, a person's age changes. It keeps on going up. Their weekly income will also change. Okay, and I could be 25, I could be 15 and years old, and I am working at Hy-Vee. Oh, wait, you're supposed to be at least, let's go 17. Or 18, that's even better. 18 years old, I'm working at Hy-Vee, and I get $9 per hour. Something like that. We're just per hour. But then I graduate. Oops. Sorry about that. Then I graduate. I'm still 18. I get a better job because I've graduated high school. And so all of a sudden now I'm making $12 per hour. Okay? So my X value can have 2 different Y values. At 18, I could be making $9. At 18, I could be making $12. So this is not a function. Okay? Good. Let's look at what your assignment is. That's it for notes. Pretty easy, huh? So here's your assignment. Compare and contrast a relation and a function. Just look at what we talked about. What's the difference? Okay, explain the definition of a function, why the vertical line test determines whether a graph is a function. I think you'll be able to figure that one out too. Try it. Okay, determine which of the following are functions. This is what we were doing before. Okay, look at your X values, look at your vertical line test. Explain whether or not each graph described represents a function. Oh yeah, draw those. Draw each of those, sketch those out. Then do your vertical line test. And then determine whether or not each relation represents a function. This is a real world problem. Think outside the box. And this would be a great discussion to have with your parents, if you're not sure on some of those, on whether you could have more than one value for that input could be more than one value. Okay? So that's a really good one to just kind of think about. The answer keys will be out in a green folder again on Schoology, so just look for that green folder for Unit 3. Then on the back, it says, you just have a fun little thing to do, because this is a pretty quick assignment. And the thing that I forgot to point out, I should have probably pointed out more on this. Everything on here is a relation. Everything is a relation. Then we have to just decide if it's a function or not. But everything is a relation. It can be written as an ordered pair, because it's pretty much everything. So you get to do this little assignment here. Determine whether each relation is a function. Indicate whether it is a function or is a relation by circling the appropriate letter in the chart. So see, is it a function? Circle one letter. Relation, circle a different letter. Okay, the answer to the title question is found by reading the circle letters in the top row, then the circle letters in the bottom row. It's just kind of a fun little thing to do. Okay, so you're going to do this one for sure. And let's do, yep, we can do both. It's a pretty short assignment. Great, thanks. If you have any questions, you know where to find us.